Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is Riemann sum. In this Riemann sum series, we were discussing about right, left and midpoint approach. We discussed about the right Riemann sum in deep in the previous video. Now let us start with the left Riemann sum approach. I'm going to use the same graph that I used in the previous video. The graph for x square plus 1. This is the graph we were using in the previous video. Now let us look at the left Riemann sum in deep. This is the graph for the function x square plus 1. Let us see what is a and b. A is this endpoint and b is this endpoint. A is 0 and b is equal to 2. Now let's find the delta x. Delta x is nothing but b minus a over n. We do not know what is n here. N depends upon the number of rectangles we draw. According to that, you can use the n value. Hope you are familiar with this formula. Okay, let us now plug in the b value and a value. We do not know n, so let that be as such. So 2 minus 0 over n is nothing but 2 over n. Now let's find x suffix I minus 1. It is nothing but a plus I minus 1 times delta x, where delta x is nothing but b minus a over n, which is 2 over n. A is 0, so just plug in a value and the delta x we just found. So by distributing this, you will be getting, I'm getting 2i over n minus 2 over n. If you combine that, you'll be getting 2i minus 2 over n. Now let us find the area of the left Riemann. So we are just going to consider only the left endpoints. So area of left side would be, hope you are familiar with the Riemann sum formula. The same formula we are going to use for the left side and the right side endpoints. So if it is for xi, you should be using the function x square plus 1, but this is for xi minus 1. So you'll be getting, this function can be written as xi minus 1 the whole square plus 1. I'm just rewriting the suffix, no other change. Delta x value is nothing but 2 over n. Now same as the right Riemann sum, we will be using some summation formula, and before that you can just distribute this. This can be written as xi minus 1 is the answer that we got in the previous step. In the place of x suffix I minus 1, we are going to use this. Here this is square, so you are going to square this. Square 2i minus 2 over n plus 1, and then you have to distribute this with 2 over n. So if I distribute and simplify, I'm getting, here already there is plus 1. This squared plus 1 2 over n. And now find the square of this using a minus b the whole square formula. Plus 1 and then distribute this. By doing so, I'm getting, hope you're clear with this part. You have to write the summation also here and then split the summation for each term. It will be easy for you to do that. By doing so, I'm getting, are you clear with this step? I'm just writing everything separately, not the common denominator, and splitting the summation. Here is where you can use the summation formula. Formula for summation I square is n times n plus 1 2n plus 1 over 6. Summation of I, so that formula is n times n plus 1 over 2. And this is going to be n, summation of 1. Now expand everything. You have to multiply each of the parentheses. You could use FOIL method also. You can first multiply n with n plus 1 and then whatever answer you're getting, you can just distribute that with the next one. After that, you multiply 8 over n cube with whatever term which is inside the parenthesis. After combining all the terms, I'm getting, I have clubbed all the terms with same denominator, so it will be easy for you to calculate it. And this is of the form n cube, n square and n. All the 6 n cubes and 2 n cubes and n square separately and a constant here. Now you have to compute the limit as n approaches infinity, similar to the right Riemann sum approach. Okay, let's now calculate it. I'm getting the same answer that I got for the previous one. N tends to infinity. So 16 over 6 plus 0 plus 0 plus 2, which is nothing but 14 over 3, which is 4.66. You can also refer a previous video on the right Riemann sum approach. You'll be getting the same answer. Okay, since limit n tends to infinity, area of the left Riemann sum is equal to the limit n tends to infinity area of the right Riemann sum, which is equal to 4.66. The area of the region must be the same thing, because even if you find the average of the both, you'll be getting the same answer. Okay, now let's also see the midpoint method approach for the same graph. Same graph, same function, a value is 0 and b equal to 2. Now area of the midpoint, you're going to use the midpoints. So f of ci times delta xi, where ci is nothing but xi plus xi minus 1 over 2, average of those two. You can use these values from the previous two sets, the right Riemann sum approach and left Riemann sum approach. Plug in the values for these two. This is 2i minus 2 over n. xi is 2i over n. Now find the average of these two. Do the fractional addition and find the average. Finally, I'm getting 2i minus 1 over n. So we have got the ci value. Now let's find the area of the midpoint. You'll be using for the formula f of x times delta x. F of x is x square plus 1, but for the midpoint it is 2i minus 1 over 2 the whole square plus 1. In the place of x we are just replacing it by 2i minus 1 over 2, and delta x is 2 over n. We are looking at this value for the past two videos. Delta x is 2 over n. Now as usual you have to expand this using a minus b the whole square formula, and then you have to distribute this. After that you'll be getting an expression same as the left and right Riemann sum approach, and finally you can apply the summation formula for each and compute the limit as n approaches infinity. Even in this method I'm getting 4.66. There is no change at all. Even if you plug in n equal to 10, you'll be getting 4.66. If you're plugging in n equal to 100, you'll be getting 4.6666. There will be no change at all. Almost they are very same. You can try this method for fun. You'll be getting the same answer. You can understand the concept from the left and right approach. You can do the same steps. Okay, and you can increase the n value as large as possible. So you'll be getting area of midpoint using n is equal to 10. Even you can take a larger n value. For 1000 I'm getting 2 more 6's. So can you guess what area for the midpoint using 10,000? It will be interesting, no? Okay, you can try that as your homework. We were discussing detailedly about the right, left and midpoint approach. What if we do, in case if we don't have a summation formula, what will we do? For example, how could we approximate the area under the graph of y equal to sin x and the above the x-axis, and x should be in between 0 and pi? So what we will do? Sine function. The f of x is equal to sin x and x will lie in between 0 and pi. Let's find the area using right and left approach. Do you know what would be the delta x? Delta x is pi over n and xi is I pi over n. Delta x is pi over n. So delta xi would be I pi over n. Now in the place of f of xi, plug in sin xi or pi I over n. In the place of delta x, just plug in pi over n. Concept is same, but we are using some different formula here. We can approximate the area using n is equal to 10. You can take this constant outside and apply the summation for this one. When n is equal to 100, I'm getting this expression. This summation expression is approximately equal to 1.9998. Does this make sense to you? Hope you're clear with both right and left approach. Okay, so whenever you get integral corresponding to the area of the region in a graph, it may be any graph, your first step should be slice it into n rectangles. It depends upon you. You can choose any number of rectangles. You can first slice it into n rectangles as shown on the graph. And then if the question is asking you to find the right hand approach, you can use the right hand endpoints, the x coordinates I mean. And then with the help of the height of the rectangle, you can plug in the right hand x coordinates into the function f of x, whatever function given in your question. One simple way to remember this formula is, hope we all know the area of the rectangle. Area of rectangle is height times width or length times width. Same way, you will be multiplying f of x with delta x. You have to just multiply, and for all the values I is equal to 1 to n, you can start from 1 till n. So you have to find the products and add them up. This is the concept. Simple basic geometry area of the rectangle concept. And finally you have to find the total area, that is nothing but our Riemann sum. In this method we will be using expanding and simplifying. Wherever possible you can use the formulas like a plus b the whole square, a minus b, any formula. Also you have to be familiarize yourself with the summation formulas. That will save so much time in multiplication and all. So that's it about Riemann sum. In case if you get any query regarding this topic, or in case if you have any request regarding the topic,